Hey guys, okay, so we need to do this problem. So this is the exponent rules. And so if you look here, guys, this is the power rule. So there's not one way you can do this, but I want you to use the power rule, okay? And the power rule says that when you have parentheses, you're going to multiply, right? You're going to distribute your power. So then, if we rewrite our problem, parenthesis 3 squared times 3 to the negative 5 to the 4th, right? What you want to do is you want to distribute. That means multiply. So 4 times negative 5, and then 4 times 2. So then, you keep your base the same, so 3, and then 2 times 4 is 8, right? That's over here. And then 4 times negative 5, keep your base, is negative 20. And now, if you look at this, isn't this the product rule? The product rule says that if you have the same base, check, and you're multiplying, check, which you are, see? Right there. You have the same base, and you're multiplying, then you can add your exponents. Okay? You can add your exponents. Now be careful. You have $8 and you spent 20. Right? Can you take away 20 from 8? No, right? So then the rule says then you can keep the base. If you have the same base and you're multiplying, you keep the base. So keep the base. And then what's 8 plus negative 20? Right? You have $8 and you spent 20. Did you have enough to spend? No. So it's subtraction, right? 20 minus the 8, which equals negative 12. So this is a good answer. So let's go check. That's not this one. It's not this one, or this one, or this one. Right? We're looking for equivalent. Now remember how we talked about negative exponents? So here's another law. Okay? Let me highlight the laws for you. So this was the product rule. Sorry about that. There's another law called the negative exponent law. But it's not really a law, right? What does negative mean? Remember, negative means opposite. And so, isn't this a number, a very small number? So it's a fraction, right? And remember, every number is over a 1. So then, if this is telling you to move the opposite, that means if this is the numerator and this is the denominator, you're going to flip it, which is called the reciprocal, and that means flip. So then, here we go. If you take your 1, you're going to flip it. It's going to go on the top in the numerator. And this number, 3 to the negative 12, is no longer, it's going to go opposite. So it's going to go to the denominator. And now you're positive, because you already went opposite. You flipped it. You did the reciprocal, which means to flip your fraction, right? Now, let's go look at our answers. Is that a possible equivalent? Here it is, 3 to the 12 over 1. So B is an answer, for sure. If they had 3 to the negative 12, that's also an answer, right? Because these are equal. And then check this out. Look at, let me use a different color. Three to the 8th times 3 to the negative 20. Isn't that this right here? 3 to the 8th times 3 to the negative 20. So that was way back, right? When we did the distributive property. So these are all good answers that are all equivalent. All right. Okay, scientific notation. Okay, this is called scientific notation, and we talked about how scientists use this to show really, really big numbers or really, really small numbers. Now, remember, keep in mind, a positive number, a positive exponent means big, right? So when you go to the right, guys, on a number line, what kind of numbers are to the right, or I'm sorry, to the left? Isn't it negative numbers? Okay, so if you see negative, that means go left. If you see a positive exponent, it means go right. Okay? So now, let's look at this exponent. You have this number, so what you do is you write down your number, 3.4, right, times 10 to the 2. So that means that you're going to move 2 place values, and because it's positive, right, because it's a positive exponent, which way is positive? To the right. So you're going to take your decimal, and you're going to go 1 placeholder, 2 tens value. So drop your decimal, and so what number do you have now? 340. So this number is this big number. 3.14 times 10 to the 2 is the same thing as 340. They're the same. Okay? Now, don't forget, you're going to add plus, so 340 plus something. We don't know what this number is. So let's go ahead and figure it out. I think it's a decimal. So take your 5.3, so 5 decimal 3, and do you notice that this is a positive 3? So that means that you're going to move your decimal to the right because it's positive. So now, ready? Here we go. 1, 2, 3. Because this is a 3, it's telling you to go to the right 3. Drop your decimal. Okay, and so what number is this? Put your tens place. Now this is 5,300. See? So that's a very fancy way of writing that number. So now you just have to do this math. 5,300 plus 340 is 5,640. Okay? So what did you learn? And a positive exponent in scientific notation, right, moves to the right. And if you have a negative exponent, right, which way are negatives? Negative numbers are to the left. So you move decimal to the left. All right. So since we just did that one, let's go ahead and do this problem. Okay, so here we are. So remember, that's a negative exponent. So which way are negative numbers? Aren't they to the left of 0? So you're going to go left. That means left. And this is a positive exponent. That means you're going to move to the right. Okay, so take your number, 5.1. So 5.1, and you're going to move your decimal to the left. 1, 2, 3, 4, 5. Drop it. Okay. Now place, now once you drop your decimal, put in your zeros. So this number is equal to this number. So 0.000051 plus, don't forget that you're adding, right? Don't forget that you're adding. Now, how big is this number? 3.1. It's a positive number, so it means it's a big number. And that means that it's positive going to the right. So take your number, 3.1, and you're going to go to the right. 1, 2, that's it, just 2. 1, 2, drop your decimal. Put in your placeholder. So now what number is that? 310. So now what's $310 plus 0.000051? It's just that. Okay? Why? Because you stack up your, oops, my bad. 310.000000. And then remember, this is 0.0. So 0.000051, right? So if you were to drop this, that's a 0, that's a 1, that's a 5, that's a 0, 0, 0, 0. Sorry, guys. It's an alarm. 310. So it's the same answer. Oops. You would use your calculator because you're going to have a calculator if you need to, okay? So again, positive exponent goes to the right, and a negative exponent means move your decimal to the left. All right. Okay, now let's look at this one. Select all the ordered pairs that apply to your function. I don't even know what that means. We're going to say satisfy. Do you guys remember that idea of satisfy? So if I have a line and I had a point here, does that point, right, x, y, because we don't know what point it is, does that point satisfy the line? Remember that? So basically I'm asking you, does this point fit the line? So it's easy to see in a picture, right? All right, but using algebra, we want to use algebra to see if it satisfies. So here's the point, right? Here's a point. And negative 2x plus 3y equals 9. That's the line. This is called a line, right? It's just written in standard form. So here's what you're going to do. You're going to take your x, that's your x value, and you're going to take your y value, and you're going to see, does that point fit in this line? And so how can we check if a point fits a line? Shouldn't we put the point in the line or put the point and see if it fits the line? So we're going to take this x, that's part of the point, and put it in and substitute, right? And you're going to take this y and substitute. So then, here's how you do it. I'm going to do a. Negative 2. Now, it's not going to be x, because don't we have an x here? So what goes in for x, right? If I'm going to substitute, if Bush isn't here, who's going to be your sub? 3. So then you take your 3, bring everything down, plus, see, plus 3. Now we're going to substitute for y. So who is y? Y is 5. So you're going to put 5. And then don't forget, equals 9, right? Because we're going to bring it down. We're just redoing the problem. So now let's go ahead and do this math. Negative 2 times 3 is negative 6. Plus 3 times 5, that's 15. Bring down your equals, 9. Remember, always bring down everything you didn't use. Keep your algebra in order. Now, be careful with integers. Here you have 6 negatives and 15 positives. Okay, so what's 15 take away 6? Right? You can rewrite it. 15 plus 6 negatives. Isn't that just 15 take away 6? So this is 9 equals 9. Is that a true statement? Check. Therefore, the point 3, 5, remember, isn't that what we're starting? Does, I guess apply is the word that they're using, but we are going to say does satisfy the line. Negative 2x plus 3y equals 9. Okay? Alright, so now you got to check this x and this y. Okay? Okay, so here we go again. Starting over, but I'm going to do this point now. Negative 2 times plus 3 times your y should equal 9. Now what is x now? Negative 5. And what is y? Negative 9. Okay, so now be careful, product laws. What's a negative times a negative? Positive. 2 times 5 is 10. Plus a positive, what's the opposite, right? Because there's only one. This is the opposite of a negative, so it's positive. So 3 times 9 is 27 negatives. Does that equal 9? That's negative 17 equals 9. Is that a true statement? Nope, false. This point does not satisfy the line. Okay, so I'm going to do one more. I'll do this one, you do this one, okay? Let's see if any more of these points actually fit the line. So we're going to take a point. That's a point. Start over. Where's your line equation? Here's your line equation. Negative 2 times x plus 3 times your y should equal 9. What's my x? 3. What's my y? Negative 1. 2 times negative 3 is 6, so negative, because it's just the opposite. Remember, that means opposite. Bring down your plus. And then 3 times 1 is 3, opposite, equals 9. You owe $6, and you owe $3, so now you owe $9, right? You got negative, so you went negative to the 6 negatives. And then you went to the left 3 more. Don't you have a total of at negative 9? Is that true that negative 9 is equal to 9? Nope. So this is not a solution. I want you to check if this is a solution. Okay, now that you know how to do that one, here we go. Same thing. You have an x here. And again, we're not looking if it applies, we're looking to see if it satisfies. Okay, and so your y is over here. Here's your x, and here's your y. You're going to substitute for x and y. Okay, I'll go ahead and do this one. Actually, you check it. You should do it yourself. But here we go. Negative 5 times y. So negative 5 times y should equal negative 12 times your x minus 7, right? So your y is negative 13, and then your x, right? Be careful, x. X is negative 6. Okay, and so now remember, how do you read this? The opposite of a negative is going to be a positive, and then 5 times 13 is 65 equals, so that's that. Remember, you're going to have a calculator, so don't panic. The opposite of a negative is going to be a positive number. So 12 times 6 is 72. And then remember, don't forget to bring down your math, minus 7. Okay. Okay, so this one, bring down your 65 equals 72 minus 7, 65. Okay, so again, you're going to have a calculator, but just in case, remember, 72 minus 7. You can't take away 7 from 2. You got to borrow. Let's borrow from 10s. So here we go. Now you got a tens place. So you got 12 minus 7, which is 5. And then this turned into a 6, so bring down your 6, so you got 65. And this right here is a true statement. And what does that mean? That means that the point x is what? Negative 6? Negative 6 comma 13, negative 13, is a solution or does satisfy negative 5y equals negative 12x minus 7, the original equation. So basically what you're saying is the point fits the line. Okay? And what's that point? Negative 6, negative 13. And this line is called negative 5y equals negative 12x minus 7. That's this line. Okay, I'll do one more. Okay, so this one was a true statement, so this is a good answer. Now I want to know, does this x and this y satisfy? Does this point fit this line? Okay, so you take your line. Okay, remember that this is your line over here. And you have to substitute for your x and your y. So here's your y and here's your x. So here we go. Take your equation, negative 5 times your y equals negative 12 times your x minus 7. Okay, so that's your equation. Negative 5 times your y equals negative 12 times your x, and then take away 7. Okay, so let's go find your x. It's 13, negative 13, right? And then take your y, which is 6. Okay. Okay, and so now you do 12 times 13 equals 156. The opposite of a negative is a positive, right? But we don't need to put a positive there. And then you take away 7. You got to bring it down. So negative 30. Is that even going to be close to equaling? Equals 91. Is that true? That these are equal? Nope. So that means that if you had a line, right? This point did not fit. This point, negative 13 comma 6, did not fit the line. ¿No tiene explicación?
No, they only teach you one of them. Just the top.
No. Go back. Tuesday. All right, so I need you to stop really quick. All right, guys, so you're gonna take your time. Go ahead and give C and D a try. And just so you know, C and D are not solutions. So the only answer is A. Okay, so pause, give it a try yourself, and then make sure that you got the same answer as me. Or maybe I made a mistake. I don't know. All right, let's go to this one. This one's kind of funny. It's easier than you think. So, if you have a book, you just got a book, and you look at it, and it has 240 pages. So your book has 240 pages. And she reads 30 pages an hour. So if you look at your variable, what are you measuring? You're measuring hours, which is your X, because on the left, and you're measuring your pages. So that's going to be your Y, because how many pages you read depends on how many hours you read. So here we go. If you read for 0 hours, well, how many pages does your book have to begin with?
0.
Don't you have 240 pages?
Mm-hmm.
It's okay. So you have 240 pages left if you don't read, right? Like that's brand new. That's your beginning. Does that sound familiar, guys? Beginning. Remember, that's your B. So if you were to create an equation in the form of y equals mx plus b, a linear equation, well, what would your B be? What's your beginning? Plus 240 pages. I should probably use white. All right, so plus 240 pages. Now, what is the rate? Remember how M stands for rate? M stands for rate. And what is your rate? How many pages per hour? Well, didn't they give us a rate, guys? They said 30 pages per hour. And so M, well, do I really need to divide 30 by 1? Well, what's 30 divided by 1? Isn't it just 30? Ah, so guys, look, we got our equation. We got y equals 30x plus 240. So if you had to create an equation, wow, this is a big mess. 30x plus 240. If you had to create an equation, there it is. Because you began at 240 and you got your rate, 30 pages per hour. Now, if you had to graph that, you begin at the y-intercept, which is your b. So if, let's just say that this is 240, right? You would have a point right here. That would be your first point, your beginning, your B. And then, oh snap, you read 20 or 30 pages per hour. So shouldn't your pages be going down for every hour? So here's 0, here's 1, 2, 3. All right, so for every time that you read, you're going to have less and less pages. So let's go ahead and do this. So now, if you don't read your book, right, you just leave it closed, how many pages are in your book? 240. All right, cool. And it says that if you read for 1 hour, let's go back to our rate, you read 30 pages an hour. 30 pages. All right, so you sat down, you read for an hour, and you read 30 pages. So shouldn't this go constantly down by 30? So this is going to be 210. And then let's say you read for another hour. And because your rate, right, isn't that a constant rate? You're going to read or go down another 30 pages. So 210 minus 30, 150, 180. I don't know why I'm like tripping on that. And then if you read for a third hour, right? Shouldn't you take away another 30? Because every hour you read, you're constantly going down or decreasing by 30 pages. So now you're at 150. And if you read for one more hour, because we said we're looking for how many pages will she have left in 4 hours. So what you did is you found, right, how many pages are left. So then minus 30 more, right? Minus 30 more. So now you have 120 pages.